Good day, everyone. This is the second of our videos on bit door grading for fixed cutter or PDC bits. On this particular video, we will be discussing the door characteristics. We'll get to see on this video the different kinds of door characteristics that it's possible that we'll have post pulling the bit out of hole. So getting right into it, this is pretty much what the module content looks at. This is the outline. We'll be looking at the door grading system of the fixed cutter bit. Post looking at that, we'll be looking at the rules for naming these doors. Then we'll be looking at the primary door characteristics that we have. At the end of the video, we'll be doing a quick review to be sure that all of us understand all the various door characteristics that we want to discuss. So the door characteristics is the third in the box when you look at how bits are graded. So you have your inner, you have your outer rows, you have the door characteristics, location where that door happened, the bearing, what happened to the bearing and seals, the gauge, other characteristics, the reason why it was pulled. Looking down here, these are the various door characteristics that can happen, from the broken cone to broken teeth, balled up, cracked cone, etc, erosion, no door characteristics. You can also have no door characteristics where the bit is pulled and you don't see anything that's happened to the bit. You can see one cutters, you can see self sharpening wear, tracking, rounded gauge, shed tail damage. There are also some door characteristics that are not IEDC or SP compliant, like the cutter delam. We'll be seeing that as the cutter delamination. We'll be seeing that as we go ahead to proceed. Please do not forget that as per SPE 23939, where all these studies were done as per bit grading, that the most prominent or the primary physical change that happened to that cutter is what you put in this first box. Say, for example, you have broken cutters and you have lost nozzles. The reason why that bit was pulled out of, or perhaps the biggest in magnitude, is what you're going to put here. So if it was broken cutters and you were getting very low ROP, was the reason why you decided to pull out of, that is the primary door characteristic that you're going to be putting on here. So let's note that that's what they're trying to say here. Then other door characteristic, which is the lower in ranking, is what you want to put in this 7 box. So the higher one you put in the third box, the lowest you put in the 7 box. So these are the various rules that we have at the back of our mind when writing those door characteristics. Number one is that the third box is dedicated for the cutter information. If there are no door characteristics, we simply say no. If there are many, pick the major. Well, I think we discussed that in the last time. Pick the major one and put it on the third box. The one which is the secondary will be put in the 7th box. Then only one cutter characteristics in that third box. So these are the various rules we will be adhering to when filling that sheet, or how when we are filling that sheet, grading our drill bits. So the first door characteristic that we'll be looking at is the no door. So this is the bit before it went to the hole. This is the bit when it came out of hole. If you look very closely, you see pretty much nothing happened. So that's why it's pretty much said to be no. Looking at this next door characteristic, it's called ER, that's erosion. So if you look at the cutters, you see that they've been eroded at different areas of the bit. If you look here, you see that all places, different places where they've been eroded. And note that it's where you will say that this bit has eroded is where you have noted erosion on the cutters and the carbide substrate, which has been used to attach the bit to attach the cutter to the body of the bit. The next you have here is, see, the flat crested wear. So if you look at the wear here, you see that the wear is flat and crested. So it's flat, pretty much flat. So here when you pick at, you see it's a little bit different with what you're going to see when you have worn cutters or when you have eroded cutters. This is pretty much flat all the way, as if a file has been used to file it all the way. Then the next we're going to be looking at is CT. That's the chipped cutter or chipped teeth. If you look at it, it's chipped on the edge. If you look at it, it's chipped here. Now, clearly, if you look at this, you will know that what probably would have caused this is axial vibration. That's pretty much beat bouncing. when the cutter it's going up and down while drilling, and when that happens, you just get that damage on the cutter. It just chips it, it breaks it out, or there's pretty much an impact with perhaps maybe part of the casing, or you have a junk on the bottom of the well that this cutter has impacted on, that can break and chip the diamond edge of your cutting. Then the next one we have is your broken cutter or broken teeth. This again, if you look at it, you see that you have parts here all broken. It's different from the flat crested here, where you agree. The flat crested is all smooth. This is broken and and has a very irregular surface. As you can see, it's all broken here while drilling. And this can also happen from axial vibration and possible impact with a junk at the bottom of the well. One cutter or teeth. Now, you see, this pretty much looks like a flat crested where, maybe because it's not uniform, that's why it's been graded as a one cutter. So you can see what you have here. It's not flat, it's not irregular. You can see these are all one cutters. So you see this will be graded as the WT. Then you have heat checking. So if what one thing you're going to use to note heat checking is that you see it's all cracked, all cracked. So you have it's one, but you have multiple cracks, and this clearly comes from when drilling and the heat from the formation. I mean, the heat due to friction. So as you're drilling, the bit is not getting properly cooled by the mud. So because it's not getting properly cooled, it heats up and it cracks this way. It heats up due to the friction of the bit rubbing across the formation while you drill. And when that happens, it heats up and you see marks like this. So when you see this, that pretty much it tells you that the your flow rate needs to be optimized. I mean, you need to get more flow down there. When you get more flow down there, it's able to cool your bit and prevent this from happening. The next one, lost cutter. This can happen. Perhaps you're drilling very abrasive formation. This can happen. Axial vibration can cause this to happen. A junk in hole can cause this to happen. So when this happens, you see you have some of your cutters broken out and pretty much leaves the substrate, no longer attached to the substrate, and falls down in the wellbore. Bond failure. So for this one, it's either a manufacturing defect. So you see the cutter is completely off the substrate. It's completely off the substrate. Not that the cutter was used up to the end. You see that clearly it's clean, it's fine. It just broke off and went off. So that tells you that it's a manufacturing defect and the cutter wasn't properly attached to the bit with the substrate. So when you see this, you clearly know that perhaps it's a manufacturing defect. Spalling. So you see this kind of looks like the heat checking, but the difference is that it happens on the diamond. So it's like the diamond cutter is peeling off. You look at it, it looks like it's peeling off. So when you see this, it's called spalling. We should know that this is not an IDC dull characteristic. It's a non-IDC. I repeat, it's a non-IDC. So if you look at your IDC manual where you're going to be grading bits, you won't find the SP, you won't find the spalling. But I just thought to add it here because it's one phenomenon that normally happens when we pull our bits. So a quick recap, looking at what we have here. So this is one door grading, this is another one. I mean, these two are the same, these two are the same, these two are the same, these two are the same. And looking at it, what do we think this door grading, what this door characteristic features are? Yes, your answer is correct. The first one is the chip cutter, because if you look at it, you see where the cutter has been chipped and broken off. As we mentioned, this can happen as a result of axial vibrations, aka bit bouncing, or perhaps an impact with a junk down in the well. The next one, yes, your answer is correct. You have a broken cutter there. So see, it's broken, it's irregular. And that can also happen as a result of axial vibration or impact with a junk in the well. The third one, yes, your answer is correct. That's a flat crested wear. So you see, it's all uniform and all. I mean, the wear is uniform and very flat, like you've used a chisel on the bit cutter. And the last one, yes, that's correct. You see at the regular wear, because of the action of the bit cutting deformation. So you see it's irregular, and yes, that's a one cutter. Yes, we have more on this slide. I'm sure we cannot remember what this is. You can see the bit, you can see the cutter away. Yes, your answer is correct. That's a bond failure. It's clearly IDC. The next one, I mentioned this. So it's one of the first ones, like non-IDC. Yes, your answer is correct. That's spalling. And finally, the last one, cutter delam. So I mentioned this at the beginning of my presentation. It's non-IDC, but clearly the cutters are delaminated and broken away from each other. So thank you very much, everyone, for listening to this video to the end. There will be more videos discussing how bits are graded. We just decided to break them into different components so that we're able to absorb them and ask our questions, make our comments on the channel. We've spoken about how the inner and outer cutters are graded. We've spoken about these door characteristics. So the next video, we'll be talking about the location of the door and the bearings. Thank you once again for watching the video. See you on the next one. Bye for now.